Okay guys, today what I'm going to do is go over the byproducts of carbs, and our basic carbohydrate again is glucose, fats, and proteins. So let's get at it. Alright, now look. These are three potential fuels. Fuels, like gas, right? Gas is burned in your car engine and it creates heat, right? That moves your piston up and down, right? That's how your car works. Well, look, what do I know? Anyways, so what we do is we eat carbs, fats, and protein. Num, 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 eat it. It gets broken down into sugars, lipids, and amino acids, and from the GI tract they're absorbed into the blood. You should write this down. I would. It's so important. I'm gonna write it down. I'm gonna say it slow too. Everything you put into your pie hole, everything you put into your mouth that gets digested and absorbed broken down and then absorbed into the blood. Into the blood. That's very important. Goes to the liver first. So the liver filters stuff on the way in, and it also filters stuff on the way out. So the liver gets rid of anything that's bad for you, like seltzer water. That could be bad for you. Now look, I'm gonna take this real slow. This is glucose, this thing right here. You don't need to know that. This is what you need to know. It's made of carbon, hydrogen, and oxygen chemically bonded together. This is fat. Look, it's made of carbon, hydrogen, and oxygen chemically bonded together, just in a different way. Then you got the amino acids, right? Look, carbon, hydrogen, oxygen, chemically bonded together. But amino acids have something that carbs and fats don't. They have this guy here. This is called the amino group. It's a bad color. It's called the amino group. That's why they're called amino acids. Now watch it. Watch it. Look. See this? It's N and 1, 2, 3 hydrogens. And when amino acids get dissolved in bodily fluids, it releases a free-floating hydrogen ion. And what did I tell you? I'll never forget it. It was a Tuesday. Anything that produces free-floating hydrogen ions is an acid. That's why they're called amino acids, because they're acids. Are you writing that down? Okay. Now, the amino group, this guy right here, you with me? That's only found in amino acids. Also, the amino group was scheduled to open up for Menudo at Summerfest, but as we know, Summerfest got canceled. Anyways, I digress. Now look, as I explained to you in the video on metabolism, you got me? You have enzymes, these little workers, and their job is to come in and break these chemical bonds. This is a chemical bond. And when you break chemical bonds, you release electrons. And these electrons have energy in them. And then inside the cell, through the metabolic pathway, these electrons are caught and then ultimately transferred into energy to take, and we learn this, adenosine diphosphate, and then that energy is used to build or add that third phosphate and convert it into ATP. So these are the fuels that you use. And also the best way, well, the best way really to do anything is completely, right? So if you're going to break down glucose, fat, or amino acids inside your cells in the metabolic pathway to make ATP, the best way to do it is completely. And when you do it completely, that means it requires oxygen. Where do you get the oxygen from? You're not going to believe this. Every once in a while you take a breath, that oxygen gets into the alveoli, it diffuses simply, by the way, into the blood, and CO2 leaves, right? And then that oxygen gets transported down to the cells of your body where it diffuses and sits at the end of the electron transport chain. So I'm not even going to get into all the chemistry. This is what I want from you. This is what I want you to understand. Glucose, to completely break it down, it requires oxygen. And when you completely break down glucose, when you completely break down the chemical bonds, because it's made of carbon, hydrogen, and oxygen, you're going to get, come on, Timmy, come on, you can do this. You're going to get carbon dioxide, wah-wah, heat, some hydrogen ions, and ATP. These, ladies and gentlemen, are the byproducts of metabolism. Alright? Now watch. If you take fat and you break down fat, and the only way you can break down fat is with oxygen. So breathe. The more you breathe, you burn more fat. The best way to burn fat, by the way, is watching videos, studying, and reading the textbook. If you saw me now, I'm anorexic. I weigh like 78 pounds because I've been reading and watching videos. Alright? Fat, watch it. CO2. Water. Can you hear those dogs barking? It's incredible. And what are you going to do? These are the byproducts of fat metabolism. When you break down fat inside the mitochondria, what do you get? CO2, wah-wah, heat, hydrogen ions, and ATP, and that's your goal. Alright, let's look at the amino acids, right? The amino acids are different. What do the amino acids have? They've got the amino group, and the amino group opened up again for menudo, or at least was supposed to. Now this is what I want. I'm telling you what I want. Apparently I failed on test number 1 to tell you what I wanted. So now I'm telling you what I want. Alright? when you eat protein, and protein isn't typically used to make ATP inside your cells, unless that's all you eat. You need the amino acids to make protein. So it wouldn't make sense to use those amino acids you need to make critical proteins and break them apart inside the cell to make ATP. That's what you have glucose and fat for. But there are times when you do use amino acids. And where do everything that you put into your pie hole that gets absorbed into the blood go? They go to the liver. So you got AA, that stands for amino acids. And what do the amino acids have? They got that NH2, that amino group, right? Now, before amino acids can be used to make energy inside the cell, what you got to do is they got to go to the liver. So look, I'm making a liver cell. How do you know it's a liver cell? I'm writing liver cell. Okay, watch it. Those amino acids are going to go to the liver. And what happens in the liver is that amino group gets hacked off. Boom. That little that amino group is getting hacked off, right? And then that hacked off amino group gets converted to this stuff. This stuff is called ammonia. That's ammonia, NH3 ammonia. Is ammonia good for you or bad for you? Say it's bad for you. You shouldn't have a captain's and ammonia, right? I'll have a gin and ammonia. This stuff is toxic. So again, the body does stuff that makes sense. And the liver takes the ammonia and converts it to a water-soluble, less toxic compound called, wait for it, urea. And urea gets dumped into the blood. Urea has nitrogen in it. Ammonia has nitrogen in it. So you got some urea, right? Lots of urea, hopefully. And then you got a little bit of ammonia, right? Right? Not too much, bad for you. And what do those contain? They contain nitrogen. So the combination of a lot of urea and a little bit of ammonia make up what's called the blood urea nitrogen. The fun. Now watch. Can you breathe out urea? Do you ever wake up and have your breath smell and it smells like urine? I've had it smell like something else, but not urine. You don't breathe out urea, typically. The only way you can get rid of urea is by filtering it out of your blood. And as you learned in general, the kidneys filter metabolic waste out of your blood. And one of the things that it filters is blood urea nitrogen, which is a waste product from protein. So one of the blood tests that a doctor looks at to determine if the kidneys are working okay is blood urea nitrogen. And blood urea nitrogen can go up or down based on how much protein you take in. So watch, here's clinical Timmy coming at you. Remember I told you that when an organ fails, all the functions of the organ fail? And one of the functions of the liver is to take the amino group, it's converted to ammonia and then urea. If the liver's failing, Can the liver convert the ammonia to urea fast enough? The answer is no. And I told you ammonia is bad for you. Bad for you. So that's why when people are in liver failure, they're put on a protein restriction in their diet. I'm jumping up and down right now. See? And here's the thing. No one will explain that to you. Go ahead. Wait, it gets better. If your blood urea nitrogen is going up in the blood, that could be an indication that your kidneys ain't working so good. So, if somebody's in renal failure, do you want them eating a lot of protein? Please say no. Please say no. That's why people who are on dialysis are put on a protein restriction in their diet. I'm jumping up and down again. You have no idea how good this information is. But you will. Hopefully it won't be too late. If you learned it now, your life would be better and clinical. But I've been doing this 18 years, and I keep saying that for 18 years. I'm going to stop. Wait, I'm not done. I'm not done. Hold up. Hold up. Watch it. You better know this, because it makes sense that I talk about it. You're not going to believe this, but inside muscle, heart, skeletal muscle, get me? You store ATP, but it's not in the form of ATP. It's in the form of this stuff called creatine phosphate. You got me? Creatine phosphate. You probably heard of bodybuilders like myself taking creatine. Not going to get into that. I'll get into that later when we talk about muscle. But creatine phosphate is the stored form of ATP in skeletal muscle. Now, when creatine is metabolized, it's metabolized to the waste product creatinine. Creatinine is the waste product of creatine, and creatinine is dumped into the blood. And you can't breathe out creatinine. The only way you can get rid of creatinine is by filtering it out of your blood. And what filters your blood? The kidneys. So the two blood tests that look at kidney function are blood urea nitrogen and creatinine. Now, here's the question for you. Of these two blood tests, 1 and B, which one is the best indicator of kidney function? And more importantly, why? Well, let's think about it for a minute. Bum, 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 bum. I like it like that. Watch. What determines blood urea nitrogen? The amount of protein you take in your diet. Does your protein intake change from day to day? The answer is yes, unless you eat the same damn thing every day. Maybe you do, I don't know. What determines the amount of creatinine produced is your muscle mass. And because you don't go to bed, typically go to bed, and you are a skinny pencil neck geek, and then you wake up and you are buffed, right? You're like Mr. Muscle. So muscle mass doesn't change much over time. Therefore, the best indicator of kidney function is the creatinine level, because it's based on the metabolism of creatine to creatinine, and that's based on your muscle mass, and your muscle mass don't change much. See how this works? So you might consider creatinine the gold standard. Get it? The gold standard. Okay. Who cares? So, you better understand that. I need you to understand that. Now, we got glucose and fat. What are the byproducts of protein metabolism? Really? Amino acid metabolism. So, we put amino acids, got the amino group, right? If we are going to use those for energy, what do you need? Yep, oxygen. What are you going to get? You're going to get carbon dioxide, water, heat, hydrogen ions, ATP. Oh wait, we got more. We got urea, ammonia, right? And that equals blood, urea, nitrogen. And just understand creatinine. It's not just, I want you to understand how creatinine and blood urea nitrogen are related. That's what I want you to understand about creatinine. Say, yeah, those are the byproducts of metabolism. I got to tell you this real quick story. I always liked this one. I don't know, this is like 20, 25 years ago. It's before I started this job, that's for sure. Anyways, you know how you get these emails? Well, back in the day, you get these just like stupid emails. So one guy, he was looking for a name of his product. He would sell his urine over the internet to people who were, you know, cuckoo for Doppel puffs or something. And they wanted, he wanted to find a name for his product so he could sell it online. And he was looking for a name. So somehow I got an email, and I don't know. So I sent back this name. You're employed. Don't you think that was a good one? He went with the Wizinator. I don't know if you ever heard of it. Just don't do drugs. Read the textbook. Okay, that's my story. I'm sticking with it. Those are the byproducts of metabolism. Come on, guys. Look.